Two spiral galaxies share our local group, yet space keeps them far apart. Andromeda hangs 2.5 million light-years from the Milky Way. That gap equals about 15 quintillion miles. Any craft leaving Earth faces timescales that dwarf every human record. Through a dark sight, Andromeda looks like a pale smudge. Your eyes gather light that left its stars 2.5 million years ago. The galaxy itself holds about 1 trillion suns. From close range, its disk would cover many full moons. Every clear night, photons from Andromeda strike Earth at the same speed limit as your own heartbeat signals. That light crossed intergalactic space long before cities, farms, or books. Telescopes split it into colors and map its spiral arms. The past reaches us during each glance skyward. Andromeda is a barred spiral, much like our own galaxy. Its central bulge glows with older stars, while dust lanes trace the arms. It may hold twice the star count of the Milky Way. Size is not the issue. Distance is. 1 light-year equals 5.9 trillion miles. Andromeda sits 2.5 million of those away. Multiply them, and the result hits 15 quintillion miles. One question remains. Who lives enough for that flight? Fastest human craft show the scale. Voyager 1 cruises near 38,000 miles per hour, far beyond the planets. After almost 50 years, it has logged about 15 billion miles. That sounds huge, until you compare it to 1 light-year. Voyager has not finished one. Put that into fractions, and it gets stranger. 15 billion miles is about 0.0025 light-year. Andromeda is 2.5 million light-years away. At Voyager speed, the trip lasts about 44 billion years. That is over 3 times the age of the universe. Even leaving the sun is slow. Voyager needed about 40 years just to cross the heliosphere edge, where solar wind fades into interstellar gas. That is only a thin shell compared with intergalactic space. The next galaxy is not outside the solar system. It is outside the Milky Way. Now raise the speed limit to light itself. Light moves about 670 million miles per hour. Covering 2.5 million light-years at that pace still takes 2.5 million years. A signal could do it. A crude craft cannot outlive it. Relativity bends the clock near light speed. Onboard time can tick slower than time on Earth. A ship might cross millions of light-years while the crew ages less. But what fraction of the calendar disappears? Take a craft that cruises at 90% of light speed. From Earth, it still needs about 2.8 million years after time dilation is included in the calendar. On board, the crew might experience about 1 million years. That is a gain, yet still beyond biology. Real propulsion stays far under light speed. At 1,000th of light speed, about 670,000 miles per hour, the trip lasts 2.5 billion years. At 1%, it falls to 250 million years. Even 10% still needs 25 million years. Laser sails and fusion designs target those fractions. A sail pushed by a ground-based beam could reach 1% of light speed without hauling fuel. A fusion craft might reach 10% if it carries heavy propellant. Even then, Andromeda stays millions of years away. Now add a far stranger option, a warp bubble. In equations, space ahead contracts while space behind stretches, letting the craft outrun light without breaking local physics. If that bubble moved 10 times light speed, Andromeda arrives in 250,000 years, still longer than all recorded human history. Between Milky Way and Andromeda lies the intergalactic medium. Matter drops to near nothing. A craft would face darkness, cold, and impacts across millions of years. What fails first? Hull, power, or crew? Space between galaxies is not empty, just almost empty. The density can fall below 1 atom per cubic yard. The temperature sits near 460 degrees below 0 Fahrenheit. A fast craft still hits dust grains at lethal energy. Shielding must last for ages. Point a space telescope into the gap, and stars thin out fast. Most frames show only faint background galaxies and a few foreground points. This is the intergalactic medium in practice. Any ship would cross it with no landmarks, only gyro data and distant light. Andromeda is not standing still. It moves toward the Milky Way at about 246,000 miles per hour. Each year, that closes roughly 2 billion miles. The change is invisible across a lifetime. Over 4 billion years, the galaxies meet. That meeting is a merger, not a crash like cars. Gravity will pull both disks into long tidal streams. Gas clouds can collide, sparking new star birth across both systems. The night sky inside the Milky Way will pack with new bands of light. Earth may not survive that long. One detail shocks people. 2 galaxies can pass through each other and still avoid star-to-star impacts. That sounds wrong. Space looks crowded in photos. What makes the odds of a hit near zero? Stars are tiny targets in a huge volume. Even in a spiral arm, the gap between stars is often many trillion miles. When galaxies interpenetrate, most stars slide past on altered orbits. The real collisions happen in gas clouds, where matter is spread out and can slam together. Close passes still leave scars. Gravity tugs on each disk and stretches streams of stars into arcs that wrap for hundreds of thousands of light years. Dark matter halos steer much of that motion, even when they cannot be photographed. The result is a reshaping that lasts over 1 billion years. After several close passes, the 2 spirals lose their neat arms. Their gas settles, star formation fades, and the combined system turns into one broad elliptical galaxy. Many stars get flung into long orbits far from the center. New globular clusters can form in the turbulence. Even with no starship, Earth is sending a trace outward. Radio and television waves spread at light speed, carrying faint patterns from our last century. Each year, that sphere grows 1 light year in radius. The leading edge is already thousands of light years from home, crossing into the galaxy's outskirts. Earth's bubble reaches Andromeda in about 2.5 million years. Andromeda is drifting closer, trimming the weight. No one knows what will receive it. Will anything answer, or will the signal fade into noise? Light and radio are the fastest messengers we know. Their arrival time is fixed by distance, not by engines. A crude craft can only chase that light. Any slower drive turns 2.5 million years into tens of millions, then hundreds of millions. Time becomes the fuel. Put the numbers side by side. Voyager speed gives about 44 billion years. 10% of light speed gives about 25 million years. A warp bubble at 10 times light speed gives 250,000 years. None fit a human lifespan. Physics sets a hard ceiling at light speed, at least for normal motion through space. Ideas like warp travel try to move space itself, not the ship. That requires exotic energy densities that no lab has produced. Until that changes, Andromeda stays a destination for math, not hardware. Yet the galaxies are not fixed points on a chart. The Milky Way and Andromeda orbit inside a group, tugging on each other through dark matter. Over 4 billion years, the sky will fill with new star fields. The trip may happen without any ship. Gravity will do the work. How long to reach Andromeda depends on speed. Today's probes would need tens of billions of years. Light would need 2.5 million years. Warp math can cut that to hundreds of thousands of years, on paper. The gap between galaxies is a lesson in scale, written in light.